Hi everyone, in this video we are going to study about the interview questions of Apache Kafka. So the only prerequisite of this video is that you should know the fundamentals of Apache Kafka. For that you can watch my video or you can study from anywhere else. Doesn't matter. I just want you to study. So without wasting any time, let's get started and study. So in this video we are going to discuss about the two questions. So first question is going to be like that if the load is of 1 million per second, it means that 1 million requests are coming every single second, and these requests are divided into three topics. It means orders, payments and notifications. So 1 million requests are coming, and some requests are for orders, some requests are for payments, and some requests are for notifications. So what kind of questions that interviewer can ask after this prerequisite? That the questions can be, how many partitions do we have to make? So in order service, in order topic, how many partitions we are going to make? In payment topic, how many partitions we are going to make? In notification topic, how many partitions we are going to make? So this can be the first question. The question can be regarding to how many brokers that we should run in our Kafka cluster. So these type of questions a interviewer can ask. So we are going to solve every single thing step by step so that you can answer every single thing that interviewer is going to ask you. Now let's move to the step 1. So we know that the 1 million requests are coming and it is divided into three topics. So that's why we are dividing it with the three. So it means that we are getting 333k request messages per second, or you can say requests per second. Now what is happening after that? I made some assumption. The assumption says that message per second per partition. It is saying that every single partition in every single second can take up to 100k to 200k request. How I take out this number? How did I take this assumption? There are two ways to take this assumption. The first way is to ask the interviewer about the RAM, CPU. According to him, each partition can handle how many requests. If he gave that number, it is perfectly fine. Or secondly, you can just say that according to the benchmarking of Kafka, I'm taking this number that each partition can solve up to 100k to 200k requests every single second. I'm talking about the partitions, I'm not talking about the topics. Each partition can solve up to 100k to 200k requests every single second. Now we know that there are three topics and each partition can solve 100k to 200k requests per second. So if we take an average, we will get 150k request. On the each topic, we are getting 333k request, and each topic we have, like, say, I don't know how many partitions are there, but each partition can solve 150k request. So what we are going to do, we are going to divide it. And when we are going to divide it, we'll get the number 2.2. So it means that when we are getting 2.2 number, it means that for convenience, we can take three partitions, and for the scalability or for our safety purpose, what we are going to do, we are going to take our partition equals to 4. So this can be the right answer, and you can give any of the answer. That you can say that I can make 3 partitions and I can make the 4 partitions according to the safety, and both the answers are right in that case. Now let me just make you revise one more time. So order topic has 330k messages per second and 4 partitions. Payment topic has again 330k messages and 4 partitions. And notification topic has 330k messages and 4 partitions. So now let's move to the step 4 and understand about the replication factor. So for the production setup, and let's say our data is very important. In that case, we need to replicate our data. So what we usually do, for the minimum number of times that we can replicate our data, it can be 3. So it means that we need at least 3 brokers. I'm not saying that is the right answer to selecting the broker. I'm just giving you a scenario to, let's say, to implement a replication factor, we'll go with a number 3 so that we can make 3 brokers. But I'm telling you one thing, that it is not the right answer right now. We will discuss about it, how many brokers we should choose in our Kafka cluster according to the request and every single thing. But for the scenario, we can just take that replication factor equals to 3, and the brokers that we are going to take is going to be 3. We will discuss about it, how many brokers we should choose in our second question. So now we know that we have 3 brokers, and let's see how our data is going to look in these 3 brokers with the help of smart broker topic partition distribution. So let's discuss about it. For that, first of all, let's see this thing. In our topic 1, we know that we have 4 partitions. So I wrote it down that topic 1 T1 is 0. It means topic 1 zeroth partition, topic 1, 1 partition, topic 1, 2 partition, and topic 3, 3 partition. Similarly with topic 2, 0 partition, topic 2, 1 partition, topic 2, 2 partition, and topic 2, 3 partition. Similarly with topic 3 as well. We are doing how I divided a topic in partition. So it is going to be like a grid matrix T10, T11. Now what will happen in that case? We have 3 brokers, broker 1, broker 2, and broker 3. What will happen for each broker? If we have 3 brokers, for some partitions, our broker 1 will become a leader. For some partitions, our broker 2 will become a leader, and for some partition, broker 3 will become a leader. So to make a proper configuration, I make in a broker 1 T10 and T11. So these two and T20 and T30 are going to become a leader. And their replications are of course going to be present in broker 2 and broker 3, but the leaders are going to be these two for the broker 1. So whenever there is a request coming to T10, it will be going to be served by the broker 1. Let's say if the request is coming on T2, so it means that broker 2 is going to serve the request of read and write on the broker 2, and broker 1 and broker 3 are going to act as a replication for this T22 partition. It means topic 2 and second partition, broker 1 and broker 3 are going to be acting as a replication, and broker 2 is going to act as a read and write, or you can say a leader. This is known as smart broker topic distribution that Kafka follows. Now let's move to step 6. Step 6 is a very common question that interviewers ask: how many consumers we should make into a consumer group. So now we know that each topic has 4 partitions. If we know that each topic has 4 partitions, so there can be 3 scenarios. So either in a consumer group we can make up to 4 consumers, we can make more than 4 consumer, or we can make less than 4 consumer. So let's see the scenarios in that case. So let's say if we have 4 partitions of one topic and 4 consumers, everything is mapped one on one. Partition 1 is served by the consumer 1, partition 2 is served by the consumer 2, partition 3 is served by the consumer 3, partition 4 is served by the consumer 4. But let's say if we have 3 consumers but 4 partitions, in that case what is happening? P3 and P4 requests are going to consumer 3. So what will happen in that case? Consumer 3 will have to serve more requests than the consumer 1 and consumer 2, and at the end when the load will increase, consumer 3 can go down because of lot of load and lot of requests are going to come on consumer 3, because both the requests, partition 3 and partition 4 requests, are being served by the consumer 3. Similarly, what will happen if we have more consumer? Let's say consumer 5 is there. If there is one more consumer, in that case we are just wasting the money, we are just using the extra resources, because consumer 5 will be remain idle because P1 is connected with a C1, P4 is connected with a C4, and so on. Because consumer 5 there is not going to be any mapping, so consumer 5 will stay idle. So in that case we can say the number of producers, so in that case we can say the number of partitions of a topic is equals to the number of consumers into a consumer group is the ideal scenario. So let's take an example that we have 330k messages per second and each message size is 1 KB, and in a single day we have 86,400 seconds. Now what will happen if I calculate it? I will get 28 TB of data. We will get 28 TB of storage that we have to use for every single topic, and we have 3 topics in our case. Then it means that 54 TB of data that we have to store every single day. So now if we take a scenario, 54 TB of data that we have to store every single day, and if we talk about the complexity of the message, let's say the message is very important, the event is very important, and it is related to payments. So we usually keep our retention policy of 7 days. That important, but if the data is not that important, we can just keep the retention policy of, let's say, 1 hour or for 1 day. So it is completely dependent on the scenario that what is the retention policy we should keep according to the data size, according to the importance of the message. So this is all about the question 1. The only thing that we didn't discuss properly in this question 1 is about the brokers. How many brokers we should choose? So let's move to the question 2 and we'll answer that too. So question 2 is also quite similar. All the questions that you are going to get from the interviews related to Apache Kafka is going to be in the same fashion, but there is going to be some tweaks in the values. And of course, when you will see this video, you are going to change the values and you will reach to the right answer. Now, in the second question, it is quite similar, but the only thing is the order is going to get 1 million messages per second, payment is getting 200k messages per second, and notification is getting 100k messages per second. So the value is not equal now. The messages are not equal. Order is getting 1 million, payment is getting 200k, and notification is getting 100k. But the whole idea is quite same. Again, the Kafka is going to solve 150k messages per second. We see this with the help of the benchmarking. Now what we are going to do, we are going to divide this 150k with 1 million, with 200k and 100k. When we divide it, we'll came to know the number of partitions that we need is going to be 10. 7 for our orders, 1 for our notification, 2 for our payments. After divide, I just figure out these three numbers, and if I sum up them, I'll get the 10. This is the number of partitions that I should make. In the previous video, I keep the replication factor equals to 3 to figure out the broker. So again, I am just keeping the replication factor equals to 3, and that is going to make 10 into 3. That is means that total number of partitions is going to be 30 partitions, including leaders and the followers. In the previous question, there was 12 partitions in leaders, but if I multiply it, so it means that 12 into 3, it is going to be 36 partitions. And the data that we were storing was 1 KB for each message. Now here we have 30 partition. So answer me this thing. If we have 30 partitions and 30 partitions are divided into 3 brokers, it means that each broker is going to handle approximately 10 partitions. So it means that when we have the 10 partition into each broker, some of them are going to be leaders and some of them are going to be follower partitions into a single broker. Now we take 3 brokers. It means that each broker is going to serve 10 partitions. Some of them will be our leader partitions and some of them are going to be follower partitions. But it is pretty sure that each broker is going to serve 10 partitions. But the scenario is now, what will happen, the load is going to increase. Let's say the order message is going to be, let's say instead of 1 million, now there are 2 million messages are coming. So what is going to happen? The partitions are going to be same, but the load is increasing. So do you think the 3 brokers will handle this case? So there is no correct answer for this question. It means that to ease the simplicity, what we can do, we can just keep it like that. We'll just increase our brokers in that case. What we are going to do, instead of 3 brokers, we are going to keep 5 brokers. So it means that each broker will now handle 6 partitions. Some of them are leaders, some of them are followers. So in that case, the load is increasing, but our broker is going to handle because it is having less partition. Why we are doing it? Because for our future growth, each broker handle less partitions and 200k messages per second. That is why we are just decreasing the number of partition into a broker. I'll say one more time that there is no correct answer of choosing the broker. You can just discuss it with the interviewer that how many partitions that we should keep into a broker and it will handle the case. So this is all for the video. I hope you understand the questions that interviewer can ask into the interviews. So thank you for watching me and let's meet in the next video and bye bye.